Welcome back, everyone. We're diving into something truly cosmic today, something that's been captivating stargazers for centuries.
Sounds intriguing.
We're talking about the Messier catalog. Ever heard of it?
Oh, absolutely. A classic.
It's a collection of 110 of the most fascinating objects in the night sky,
From shimmering star clusters to swirling galaxies.
even the remnants of exploded stars.
A real cosmic variety show.
Exactly. But imagine yourself back in the 18th century. You're an astronomer, passionate about comets, spending every night scanning the skies.
Hoping to catch a glimpse of one of those elusive streaks of light.
But there's a catch. You keep getting distracted by these fuzzy patches that look kind of like comets, but aren't.
Frustrating, right?
Absolutely. And that's precisely what led Charles Messier to create his now famous catalog.
It wasn't meant to be a best of the universe guide, but more like a not a comet list.
A comet hunter's cheat sheet. I love it.
Exactly. His first catalog, back in 1774, had just 45 objects.
It's grown a bit since then, huh?
Oh, definitely. By 1781, it had expanded to 103 objects.
And today?
It includes a grand total of 110.
Amazing. From a frustration-fueled project to a cornerstone of astronomy. And it's not just a historical relic, right?
Not at all. Astronomers still use the Messier catalog today.
Really?
It's a treasure trove of bright, easily observable deep sky objects.
So it's perfect for both amateur and professional astronomers.
Exactly. Plus, studying these objects has led to incredible discoveries about stellar evolution, galactic dynamics.
And the sheer vastness of the universe.
It really puts things into perspective.
So what kind of objects are we actually talking about here? What was Messier trying to avoid besides comets?
Well, the Messier catalog is incredibly diverse. It includes three main categories: globular clusters, open clusters, and nebulae.
Like a sampler platter of the universe's greatest hits.
Exactly.
Okay, I'm already hooked. Let's start with those globular clusters. I've seen pictures, they look absolutely breathtaking, like giant swarms of stars.
They are. Imagine hundreds of thousands, even millions of stars packed together by gravity.
Into a dense spherical structure.
They're like ancient stellar cities, some of the oldest objects in our galaxy.
Wow. Makes you feel pretty insignificant, doesn't it?
It does, but in a good way, I think. It puts things into perspective.
And can we actually see these clusters from Earth?
Many of them, yes. Even with a good pair of binoculars, you can see some of the brighter ones.
Okay.
M13 in the constellation Hercules, it looks like a fuzzy ball of light to the naked eye, but
But with higher magnification.
you can resolve individual stars. It's an awe-inspiring sight.
Definitely adding that to my stargazing list. Okay, so how do these globular clusters differ from open clusters?
Think of open clusters as younger, more loosely bound groups of stars,
Often found where?
often found in the spiral arms of galaxies like our own Milky Way.
So open clusters are like the newborns, and globular clusters are the wise elders of the universe.
Precisely. They represent different stages in the life cycle of stars and star clusters.
Fascinating. Okay, what about nebulae? Those are the clouds of gas and dust, right?
That's right. Vast, often colorful clouds.
They're like the artists of the cosmos, creating those stunning visuals we see in space photos.
I love that analogy, and they play a crucial role in the life and death of stars.
Really? How so?
Well, some nebulae are stellar nurseries, where new stars are born from collapsing clouds of gas and dust.
Like cosmic cradles.
Precisely. Others are the remnants of dying stars, like planetary nebulae.
Where a star has shed its outer layers into space, creating those beautiful and intricate patterns.
Exactly.
Wow, so nebulae aren't just pretty pictures, they're active participants in the cosmic drama of stellar life and death.
They're essential.
So let's dive into a few of the standout performers in this cosmic variety show. We've talked about the general categories, but are there any specific objects from the catalog that really capture the imagination?
Oh, there's so many. Where should we even begin?
How about something iconic, something that even people who don't spend their nights stargazing might recognize?
Okay, I like that.
Let's go with the Orion Nebula. Who hasn't been captivated by that glowing cloud in Orion's sword?
It's one of those sights that makes you stop and just stare up in awe.
Definitely.
And for good reason. The Orion Nebula, or M42 in the Messier catalog, is a stellar nursery where new stars are being born right now,
Wait now.
as we speak. And it's relatively close, astronomically speaking.
Yeah,
You can actually see it with the naked eye on a clear night.
No way.
Even a small telescope reveals incredible detail. swirling clouds of gas and dust, illuminated by the light of hot, young stars.
It's like a window into the process of star formation happening right before our eyes.
It is.
And while we're talking iconic objects, we can't forget about the Andromeda Galaxy, M31, our galactic neighbor, right?
Absolutely. Andromeda is a spiral galaxy, much like our own Milky Way, but even larger.
Wow.
It's so close that you can actually see it with the naked eye, too.
Seriously, what does it look like?
Just a faint smudge of light, but through a telescope, you start to see its structure, those spiral arms swirling around the central bulge.
It's a humbling reminder that our galaxy is just one of billions out there.
Billions upon billions.
Mind-blowing to think about all those stars and the possibility of other planets.
Maybe even other life forms out there.
Okay, so we've got star clusters, nebulae, even galaxies on this list. Is there anything else we need to know to appreciate the full scope of the Messier catalog?
Well, it's helpful to understand the distinction between deep sky objects and the things we're more familiar with, like stars and planets.
Okay, so deep sky objects are essentially everything beyond our solar system.
That's a good way to put it. Everything that's not a star or a planet orbiting a star.
The distant realms of the cosmos. The grand structures and stellar nurseries that lie beyond our immediate cosmic neighborhood.
Exactly.
And the Messier catalog is a fantastic guide to exploring those realms.
It is a roadmap to the universe's most fascinating objects.
Well, then let's dive deeper.
I'm ready.
Let's explore some of these categories in more detail, starting with
Yeah.
those mysterious and beautiful nebulae.
That's good to me. Let's unravel those cosmic clouds.
They're so much more than just pretty pictures, aren't they?
Oh, definitely. Much more. Nebulae, huh? They really are like these, well, interstellar art galleries of the cosmos.
I love that analogy. Each one a unique masterpiece sculpted by stellar winds, radiation, and gravity.
Exactly, but there's so much more to them than just aesthetics.
Right, they play a crucial role in the life cycle of stars.
Absolutely. They're both the birthplaces and the graveyards of stars.
Both. That's interesting.
Some nebulae, like the Orion Nebula we talked about, are these active star-forming regions.
Oh, I see. So they're full of these vast clouds of gas and dust.
And gravity just pulls all this material together, causing it to collapse and heat up, eventually.
What happens?
The core of that collapsing cloud gets so dense and so hot that nuclear fusion ignites, boom, a star is born.
So nebulae are like cosmic wombs nurturing those baby stars. But you said they're graveyards, too.
I did. When a star reaches the end of its life, depending on its size, it can go out in a blaze of glory, or it can kind of fade away more gently.
But either way.
It leaves behind a nebula.
Okay, I'm following.
Take our sun, for example. When it runs out of fuel, it'll expand into a red giant, shedding its outer layers into space.
And that creates
A planetary nebula.
which is
A glowing shell of gas surrounding the dying star's core.
So those planetary nebulae are like the star's final farewell, a cosmic swan song, almost.
Beautiful way to put it. And they're responsible for some of those really intricate and beautiful shapes we see in nebulae.
The rings, spirals,
Even those bipolar structures with lobes extending in opposite directions.
each one with its own unique personality.
Shaped by the star's rotation, magnetic fields, whether it was a single star or part of a binary system.
It's amazing how much variety there is.
Yeah.
But these aren't just visual spectacles, right? They're also like recycling centers for the universe.
You got it. The material ejected by that dying star is enriched with heavier elements that were forged in its core during its lifetime.
Like,
Think carbon, oxygen, even iron.
wow. And what happens to that material?
It gets dispersed into the interstellar medium, enriching the nebulae from which new stars will eventually form.
So it's a beautiful cycle. Stars are born from nebulae, they live out their lives, and then they return their enriched material to the nebula.
Seeding the next generation of stars and planets.
A cosmic circle of life. I love it.
It really is. And speaking of stellar deaths, we can't forget about the most dramatic end-of-life event for a star.
A supernova.
You got it. Now, those are the real cosmic fireworks shows.
The images of supernova remnants are absolutely stunning.
They are. Supernovae are the cataclysmic deaths of massive stars, at least 8 times the mass of our sun.
8 times. That's huge.
When these stars exhaust their nuclear fuel, their cores collapse incredibly rapidly.
Okay.
It triggers a shockwave that rips the star apart in this brilliant explosion.
Sounds incredibly violent,
Yeah.
but also incredibly creative. What happens to all that material that gets blasted out into space?
It forms a supernova remnant, an expanding cloud of gas and dust enriched with the heavy elements forged in the heart of that dying star.
So they're like the echoes of these massive explosions still rippling through the cosmos.
Exactly. And they can persist for thousands of years, gradually fading as they interact with their surroundings.
And they're not just visually stunning, right?
Right.
They also play a crucial role in seeding the universe with the elements that are essential for life, don't they?
Absolutely. The calcium in our bones, the iron in our blood, these elements were created in the hearts of stars and scattered throughout the universe by supernovae.
We are literally made of stardust.
It's true.
That's incredible. We owe our very existence to these explosive events that happened billions of years ago.
It really puts our place in the universe into perspective.
Mm.
And while we're on the subject of the big picture, let's shift our focus from the deaths of stars to the grand structures that house them. Galaxies.
Galaxies, those vast islands of stars, like our own Milky Way.
Exactly. Galaxies are these collections of stars, gas, dust, and dark matter, all bound together by gravity.
They're the building blocks of the large-scale structure of the universe. And they come in such a variety of shapes and sizes.
They do.
I know our Milky Way is a spiral galaxy, but what exactly does that mean?
Well, a spiral galaxy has this central bulge of stars surrounded by a flat, rotating disk of stars, gas, and dust.
I'm picturing it.
Within this disk, you have spiral arms, regions of enhanced star formation.
So those spiral arms are like cosmic nurseries where new stars are constantly being born.
Precisely. And the spiral arms aren't the only interesting features. Spiral galaxies also have halos.
Halos. What are those?
Vast spherical regions surrounding the disk containing globular clusters and streams of stars.
It sounds like there's a lot going on within a galaxy. And I know there are other types of galaxies besides spirals, right?
Oh, yeah.
Okay.
Elliptical galaxies, which are smooth and oval-shaped, lacking the spiral arms of their counterparts. And then you have irregular galaxies, which have no defined shape and are often the result of galactic mergers or interactions.
So it's a pretty diverse cosmic zoo out there, with galaxies of all shapes and sizes. But galaxies aren't just solitary wanderers, are they?
Nope.
Don't they group together as well?
They do. Galaxies are often found in groups or clusters, bound together by gravity. Our Milky Way, for example, is part of the local group.
The local group.
It contains about 50 galaxies, including the Andromeda Galaxy.
Wait, so our Milky Way is part of a galactic group. And that group is probably part of an even larger structure.
Like those Russian nesting dolls, but with galaxies.
Exactly.
And yes, these groups can be part of even larger structures called superclusters.
The clusters.
Vast filaments and sheets of galaxies spanning hundreds of millions of light years.
It's mind-boggling to think about the scale of the universe. So we've got galaxies, groups of galaxies, then these massive superclusters. Is there anything bigger than a supercluster?
That's a question astronomers are still trying to answer. We're constantly pushing the limits of our understanding of the universe, exploring the largest scales and the earliest moments of cosmic history.
That's what makes astronomy so fascinating. We keep making new discoveries, pushing the boundaries of knowledge.
Exactly. And it all started with people like Charles Messier, who simply wanted to avoid mistaking fuzzy patches in the sky for comets. His catalog, created out of frustration, has become a cornerstone of astronomy.
Inspiring generations of stargazers and scientists to explore the wonders of the universe. And the best part is, many of these objects can be observed with relatively simple equipment.
You don't need a giant observatory to experience the awe and wonder of the Messier catalog.
That's so cool.
Even a good pair of binoculars or a small telescope can reveal a surprising amount of detail. So if you're ever feeling a little lost or insignificant, just look up at the night sky.
All those twinkling stars, those faint fuddies.
They're all part of this vast and interconnected cosmic web.
And you, my friend, are part of that web too.
Yeah.
You've inspired me. I'm ready to embark on my own Messier marathon, but where do I even begin?
Well, the good news is you don't need a fancy observatory or really expensive equipment to actually enjoy the Messier catalog.
Okay, good.
A lot of these objects are visible with, just a pair of binoculars or a small telescope.
That's a relief. But I have to admit, I'm like totally a novice when it comes to stargazing.
Yeah.
Any tips for a beginner like me?
Absolutely. First, I would recommend finding a dark sky location. Get away from the city lights.
Makes sense. Light pollution washes out the fainter objects, right?
Exactly. Getting away from that urban glow will really make a huge difference in what you can see.
Even driving a short distance away from the city can dramatically improve your view of the night sky, I've heard.
Oh, yeah, for sure. And Once you've found a good spot, you'll need a star chart or a planetarium app to kind of help you navigate the night sky.
Okay.
These can show you the constellations and actually pinpoint the locations of the Messier objects.
There are some pretty amazing apps out there these days. They even show you the best viewing times for specific objects, like based on your location and the time of year.
Oh yeah, technology has definitely made stargazing so much more accessible. So once you've kind of got your bearings, start with some of the easier targets.
Like what?
The Pleiades star cluster, also known as the Seven Sisters, is a great starting point.
I've heard of that. It's visible to the naked eye, right?
It is. In the constellation Taurus,
Isn't that an open cluster?
it is a beautiful group of young stars, relatively close to Earth. Another one that's pretty easy to spot is the Beehive cluster
And where's that?
in the constellation Cancer. It looks like a fuzzy hatch of light to the naked eye, but with binoculars or a telescope, you can actually resolve individual stars.
Okay, those are going on my list. And what about something a little more challenging? Say, for someone who's graduated from binoculars to a small telescope.
Well, the Orion Nebula is always a crowd pleaser.
We've talked about that one.
It's bright, easy to find, and incredibly rewarding to view through a telescope. You can actually see the swirling clouds of gas and dust, the trapezium cluster of young stars at its heart, even hints of color.
And that's in the constellation Orion, right?
Yeah.
Easy enough to find, even for a beginner like me.
Exactly. And once you've mastered those, there are literally over 100 other messy objects just waiting to be discovered.
Right.
From the Whirlpool Galaxy with its amazing spiral arms to the Ring Nebula, which is a planetary nebula shaped like a glowing smoke ring. There's just something for everyone in the Messier catalog.
It sounds like such an incredible journey of cosmic exploration. I have to ask, what's the most rewarding part of observing these objects for you? Is it the visual beauty, the sense of scale?
You know, it's all of that and more. For me, it's that feeling of connection, of realizing that we are part of something so much larger than ourselves.
I feel it.
When you look up at the night sky and you actually see these distant objects, these galaxies and nebulae, it's humbling, really. It puts our everyday worries into perspective and reminds us of just, like, the beauty and the vastness of the universe.
It's not just about the objects themselves. It's about the awe and wonder they inspire in us. That realization that we're part of this grand cosmic story, a story that's still unfolding.
Exactly. And the Messier catalog is a fantastic entry point into that story. It's this reminder that scientific discovery can come from the most unexpected places.
And that curiosity and a passion for exploration can lead to some truly incredible insights.
Couldn't have said it better myself.
So to all our listeners out there, we really encourage you to get out there and explore the night sky. Embrace that curiosity that Charles Messier had centuries ago. You might just be surprised by what you discover.
And by the sense of wonder it ignites within you.
Keep looking up, everyone, and keep exploring.